Algebra 2, Common Core, solving rational equations. So rational equations essentially are, fractional type of equations. And to start off here, we have some very basic examples of fractional equations. So solve the following equations for x and give evidence that your solutions are correct. Basically, check your answer. Now, there's really two types of rational equations you're going to see. One where it's a fraction equal a fraction, a single fraction equal to a single fraction. This is called a proportion. And you could solve a proportion through cross multiplication. It is not the only way to solve a proportion, but it tends to be the easiest, tends to be the best. The one that students like the most. You do not need a common denominator. You don't need to do anything special. Just cross multiply. And so we'll multiply, this x plus 3 times 6. And of course, we need to distribute when we multiply. That's going to give us 6x plus 6, 12, 18. And 12 times 5 is 60. Then we can just solve this little equation here. Subtract 18. That looks like it's going to be 42. And, excuse me, sorry about that. And so then we, divide by 6, and 42 divided by 6 is 7. Now, how can we give evidence? How can we show this is correct? Well, if we plug 7 in, the way you check most equations, if you simply substitute your solution into the equation, we plug 7 in there. 7 plus 3 is 10 over 12 equals 5 over 6. And again, you could cross multiply and you can see that 60 equals 60, or you could see that 10 divided by 12 simplifies to 5 over 6, or I could top this divided by this to get the decimal equivalent of, and I see that both of them are going to come out to be, 0.83 repeating. Same thing with 12, but that's a pretty easy one. You can see that that is correct. Now, this is not a proportion, this next example here. It's not a proportion because it's not a single fraction equal to it. There's several fractions. There's two different fractions over on the left side, and then there's a third fraction on the right side. So it's not a proportion, so we cannot cross multiply. If we wanted to cross multiply, we could, but what we would have to do is combine this to be a single fraction somehow. Now, it would actually be very easy here because they have a common denominator. You can just write it as 2x plus 5 over a single 9. And then cross multiply. But what this problem is attempting to show you is that when you have a common denominator of all your terms, you simply don't need it. And you could just solve what's up top. There's no reason in dividing everything by 9 if they're all being divided by the same thing. So if you could get a common denominator, and we could use that for these other methods too. If we get everything to be over the same thing, we could simply cross it out and be done with it. And so we'll minus 5 to get 3, and we're going to get a fraction answer here of 3 over 2, or 1.5 as a decimal. And we could check that. 2 times 1.5 is 3, and this would be a third, 3 over 9 plus 5 over 9 is the same thing as 8 over 9, so it does check out. Now, these are very basic examples, so simple that you won't see problems like that. You'll see things like this. So how do we solve this? Now, the method that this video is going to illustrate is a method that's called clearing denominators method. And this is simply what I recommend. There are other methods. As I pointed out up here, we could get a common denominator and then cross it out. For example, this first, this is a denominator of 2, denominator of 6, and this number 2 would have a denominator of 1. Anytime you have a constant that, or anything that is not a fraction, you can put it over 1. Well, I can get all of these to be 6s. I can multiply that by 3, but I have to do top and bottom. I can multiply this by 6 and top and bottom, and then they'd all be over 6, and I can cross it out. And you can do that. You could do that in my class. You could do that on my test. You could do that on the Regents, of course. You could use a common denominator method. I choose to use a clearing denominators method because it's a little bit, at this level, it really doesn't matter, but when we get to the more complicated questions like this, the clearing denominators method is much easier than a common denominator when it comes to expressions and things like that. So I'm going to show you the clearing denominators method, but there is a disclaimer here that there are other methods to doing this, and you're welcome to do another method if you prefer that. But the video here, I'm going to use clearing denominators, and that's what I'll use mostly in class. So the way we clear denominators, this explains, is multiply each term in the equation by the denominator to eliminate the fraction. What that means is I got to look at these one at a time. There is a way to actually do them all at once using something called the LCD, but I'm not going to show you that either. I'm going to do them one at a time. The most simplest way to do this, and it may even be more work than other methods, but I do feel that it is the easiest to understand why it works and easiest to follow. So one at a time. My first denominator is 2. And so what I need to do then is multiply each term by 2. Not 2 over 2, again, because I'm not trying to get a common denominator, I'm trying to clear the denominator. So multiply everything by 2. And usually we write it up top at the numerators. If anything, I'm multiplying by 2 over 1, not 2 over 2. The fraction that has that denominator, that simply cancels out because I'm doing times 2, and a denominator of 2 is the same thing as divided by 2. Like this is x divided by 2. A fraction is a numerator divided by a denominator. So when I multiply by 2, the times 2 divide 2 cancel each other out, and I'm left with just what was the numerator, x plus. Now for the second fraction, I have a choice. I can just multiply the top as 2 times x and make it 2x over 6, or I could reduce along the way. Again, that's really kind of your option. I like to reduce along the way. What I mean by is I can't cross out the 2 and the 6 like I did the 2 and the 2, but I can simplify them. Times 2 and divide by 6, it's kind of like what can I divide them both by? They both can be divided by 2. And so this 2 gets simplified to a 1, and this 6 gets simplified to a 3. And so this fraction becomes 1 times x is x over 3. Like I said, if you didn't follow that, if you'd rather make it 2x over 6, that's fine, you can. It's going to work both ways. And then on the right side over here, multiplying by 2, I had a denominator of 1. That doesn't simplify at all, so that just becomes 2 times 2 is 4. And I'm not going to write it over 1 because the whole point of this is to eliminate the fractions. All right, so by multiplying by 2, I got rid of that denominator, and this one wasn't really there to begin with. So I'm left with, and this 6 got simplified when I multiplied it by 2. I'm left with a denominator of 3. So now I'm going to multiply everything by 3. The first piece here, first term, 3 times x is 3x. I don't know why I wrote an equal sign, just 3x, then plus. The second term was the term that had the denominator 3, so the times 3 and divide 3 cancel each other out. I'm left with just what was the numerator, x, and then I have 4 times 3, 12. By clearing the denominators one at one, what this does is it results in an equation with no fractions, and now I just solve it with normal methods, 3x plus x, 4x equals 12, x equals 3. And I could plug that in to verify that it works, but you could just take my word for it right now to save some time. All right, let's try that again over here. All right, so my first denominator is 3, so I'm going to multiply everything by 3. The first fraction is the one that had that denominator, so they cancel out. I'm left with just the numerator that was there, x. Here, I'm going to have to distribute this 3. It cannot be simplified with the denominator of 2 that was there. So this fraction is going to stay something over 2. But I'll distribute that 3 into the x plus 1 to make it 3x plus 3. And on the right side, I have 3 times x to be 3x. The denominator that's left is 2, so I'll multiply everything by times 2. First term, 2 times x is 2x. The second term, the times 2 divide 2 cancel out. Again, I don't know why I put an equal sign there. 2x plus 3x plus 3. And 3x times 2 is 6x. Fractions are gone, so just combine like terms and go. That's 5x plus 3 equals 6x. I'm going to end up with 3 equals x. Again, I could plug it in to check it. Take my word for it. It works. Now, what happens when we have denominators that are a little bit more complicated, such as x minus 2? So these are rational equations with variable denominators. When a denominator contains a variable, you must first state the value or values the variable cannot be. And this is a form of extraneous solutions. And we saw that when we had the square root, the radical equations, that a square root couldn't equal a negative. And there were other times where that rejected. But we can see that kind of here too, that sometimes there are some things that x cannot equal. And we need to state that. And so you want to look at the denominator before you even get into solving the problem. Any denominator that has an x, what would make it 0? And if you can't do the work in your head, you could off to the side somewhere, take that denominator and set it equal to 0 and solve it. And we would end up with x equals 2. And so what we're saying here is that if x comes out to be 2, I'm going to have to reject it because x cannot equal 2. So you have to state the values x cannot be, and that's what we just did. X cannot equal 2. Because if it was, this particular fraction would be 5 over 0, and that is what's called undefined. You cannot have a denominator of 0. All right, so we stated that. Now let's get into solving it. We're going to clear the denominators just as we did, for these problems here. My first denominator is 2. So I'll multiply everything by times 2, times 2, times 2. The first fraction, it cancels out because that was the one that had the 2. I'm left with just the numerator 1 plus. Now this second piece, I'm multiplying by 2. The denominator is x minus 2. That is not the same thing. Like if I had 2 over x minus 2, I can't cross out these pieces because this is a polynomial, this x minus 2. And so I would need another x minus 2 to simplify or cross out. You can't reduce a monomial and a polynomial and this type of thing, because this is held together with subtraction, and when we cross out, it's a form of division, and those two operations don't undo each other. So that actually cannot be simplified, so my denominator will stay x minus 2. When in doubt, don't simplify. Leave the denominator at what it is and just multiply the numerators. So, what you were multiplying to clear out. So 2 times 5 is 10. Like I mentioned earlier, we could have done that here. Like I could have made this 2x over 6, but I chose to make it x over 3. It works both ways. So when in doubt, if you're not sure about the simplifying, don't simplify and just multiply the top, keep the bottom what it is. And over here I have 3 times 2, 6. All right, lastly, now my denominator is an expression x minus 2, but I'm going to multiply everything by that expression x minus 2, just as if it were a number. Whatever the denominator is, I multiply everything by that. It's going to require some distribution here, but that one's just x minus 2 plus. Here it crosses out just like, I did when I had the denominator that has that term. And here I'll have to distribute a little bit to get, so that was plus 10. So that's left over. Numerator, 6x minus 12. And so over here I have x plus 8 equals 6x minus 12. And now the problem gets easy. We'll add 12 to get 20, minus x to get 5x, and x equals 4. And that's going to be the answer because the only extraneous answer would have been 2. That's why we want to start by stating what x can't be. And that really is part of the answer, that x is 4 and x does not equal 2. Extraneous answers, we cross them out and we write reject. We don't have to write reject here, but we cross them out, but they are part of the work, so you do need to show those extraneous solutions. So that's why we want to do that right away for these types of equations. All right, so this is rational expression equations. Proportions, just cross multiply, common denominator. And so there are other methods like common denominator methods, but if you multiply out your denominators one at a time and you're careful with the algebra, you could end up with an equation that has no fractions, and you just solve with normal methods. All right, that's it for rational expression equations. See you later.